Here's the deal. I'm going to throw some, put it in, right on that bag, right on that orange bag for me, on my orange bag. All right. Listen carefully to this. Guys, what I'm going to talk about today is going to be stuff we've already covered. We're just going to start changing the notation and the way we write sequences compared to what we have been doing. It's going to be pretty similar, but there's going to be some rules and some notation that you see that looks very difficult. I think if you follow along with me and just take your time and say, oh, that's what that means. Oh, that's what that means. I think this will make total sense to you. All right? So here's a question for you. You know how to do this. Here's a question. I'm going to keep writing until you identify a pattern.
It's adding by 4.
Adding by 4.
So listen to what I say here. What term or what value do I have right now?
27.
What's the next term?
31.
31. What do you have now?
31.
What's the next?
35.
What do you have now?
35.
What's next?
39.
What words am I stressing?
Next
Next and now, next and now, next and now. All right? You understand what I was doing up there when I said, what do you have now? What's next? What do you have now? What's next? Right? If you can start thinking that way right now, what do you have right now? Okay, what's next? Got that. What do you have now? Now what's next?
Carter Sport and Tate Hookham, you need to get down here for the swim team. Carter Sport and Tate Hookham.
Yeah, Carter. Hey, it's recording.
I don't care. Fuck me.
Where did this come from? Burn.
Feeling high and
All right.
mighty today?
Huh?
Feeling high and mighty?
You know what? High and mighty, whatever you want to say. I don't care
You're
anymore.
recording.
I don't care.
Did you not just say that?
It's Friday.
Still.
All right.
Do you know what I said?
Next one. You ready? Watch this. 4, 8,
Number.
16.
Going by 4. No, you're
What's next?
32.
Huh?
32.
32. What do you have now?
32.
So what's next?
4.
All right, so let me ask this question. Are we still trying to identify patterns?
Yeah.
We are, right? We are still trying to identify patterns. So that's going to be important, okay? But I want you to understand and say this. The way I find that next term, thank you. The way I find that next term is to use what you have now and apply that pattern to get that next term. And we're going to look at how that ties into what we call recursive defined sequences. Recursively defined sequences right here. Okay, I'll show you what this means, and I think you'll catch on to this pretty well. I need you to do something in your notes real quickly, just some housekeeping stuff. First of all, go to your last page in your notes. And we're not going to do example 5, so why don't you just get rid of that, okay? All right, so get rid of example 5 in your notes. We're not going to do that. And then if you would do me a huge favor, and this is going to be really important for you guys, we're not going to test a whole lot over this, but I will tell you on the test for some of the recursive rules, I will tell you example 2 will be something that's going to be on your test. So you will see a test question very similar to example 2 here.
Do it like this. I went like this. It's the same way. If I went like this.
Okay? You guys have that down? Example 2? You will see a test question like that on example 2, all right?
You wrote it like this. Like that. And then when I wrote
I
it
will put a stoplight up here.
this, when I looked at it, like this.
Say hi to you.
So the lines were going still up.
Everybody?
No, they were not. Hey, they are.
All right. Here we go. Guys, the question we need to ask today is how do you define a sequence recursively? First of all, we need to understand what this stuff is down here. I'm going to read you the goals here. I'm going to kind of tell you what the vocab means. Part of this vocab we know. It's stuff we've done. We just haven't talked about it in terms that we have here. But the first goal that I have is to write terms of a recursively defined sequence. We're going to write some rules for those sequences. We want to be able to translate between recursive and explicit rules, vice versa. And then we're not going to worry about this last goal. That's the one that we crossed off in example 5. So I'm not going to worry about this one here. So cross that off. And it probably makes some sense if we knew what a recursive formula or recursive sequence was first, right? How many have ever heard of a recursive sequence? Anybody? Anybody ever heard of recursive? Have you heard of stuff that reoccurs before?
Yeah.
Yeah.
Kind of think of it that way. I think that's a good way to kind of remember this. All right, let's get some definitions out of the way. I'm not going to necessarily read through this right here, but the first thing that we have up here is an explicit rule. Guys, that last section of geometric sequences, we had a formula that would define the nth term of any geometric sequence. What was that formula? All right, so the nth term equals
Is it A?
A.
1 and R.
Did you say the first term?
Yeah. A1
Times R, where R is your common ratio to the n minus 1 power, right? And this is what kind of a sequence? That's a formula for what type of a sequence? Geometric. Thanks, Mason. Very good. Geometric. Now, guys, I'm going to put another one up here. We talked about this a couple months ago, I believe. So if you've forgotten, that's okay. But the other one was considered arithmetic. Instead of having a common ratio, we had a common difference. By how much was the pattern moving up each time? Was it going up plus 2, plus 3, plus 5, plus 7? Okay. Anybody remember that formula?
Yes.
Do you remember it, Joe? I'll put it up here.
I did.
First term plus the quantity n minus 1 times d, where d represented the common difference, how much you were moving up. All right, and this was going to be the explicit rule that defined any arithmetic sequence. So guys, we've had two formulas that talk about defining sequences. Write me an explicit rule for a sequence. That's what that definition means. It basically means you're able to define arithmetic and geometric sequences that gives the nth term as a function of the term's position number n in any sequence. Basically, explicit rule means use this formula or this formula. This is stuff you have had before. You know this. You know this. And we'll look at some examples and tie that in today. Now, what's new for you guys today is the following. This stuff is new. And this stuff is very weird, right? And I think that's why I kind of like it. It's very new, and I think this is very weird. All right, I think this is very new and very weird. Oh, I'm sorry.
It's going.
Where are you going?
Baby.
Oh.
Is it going to take you the rest of that? Why are you bringing that back?
All right. Why are you taking a backpack?
Well, you're not going to do anything when you bring this
Yep.
anyway.
All right.
Yep.
Guys, your recursive rule right here is any rule to define an arithmetic sequence that gives the, I'm going to underline some stuff. You underline the following stuff here. That gives the, what's the phrase I'm underlining here? The beginning terms of a sequence, and then a recursive equation that tells how the nth term is related to one or more preceding terms. I'm going to put some stuff down in this box right here that is very important. All right? This stuff is important. If you don't, I'll tell you what, if you don't listen to this part right here, I guarantee you won't get anything right.
What's the thing next to? Oh, important. Got
This
it.
stuff is very important right here in this box. All right, so if you don't hear anything all day, hear this. Because if you don't hear any of this, you're not going to get any of what we're doing today.
Gotcha.
Promise you. All right, here's the deal. Guys, it said right here, it said that you need to have some beginning terms. In other words, you need to have a starting point. What's your first term? You need to know the first term. So one thing that you will need to know for sure is your starting point. You need to know what you're starting with. In other words, you need to know the first term for sure. Sometimes you might need to know the second. But you definitely need to know the value of the first term. Any recursive sequence, you need to know the first term. You have to know that. Now, there's some notational stuff that goes on. There's some notational stuff that goes on. Remember how I started out by saying, here's a sequence. What do you have now? And then what do you have next? What do you have now? What do you have next? And you were able to answer those questions, right? Okay, notationally, this is what I want you to know about recursive formulas. I'm going to write stuff in terms of a next and a now term. And what I want you to just write down right here is this. When I start talking about what's next and what's now right here, we're going to replace this word next with the nth term. So anytime I use the word next right here, what am I replacing it with? A of n. If I ever use a now term, this is like the preceding term. This is like a of n minus 1. Okay, the next term and the now term. Doesn't the next term come right after what you have now? So think of it this way. If I have the third term right now, what's next? If I have the third term right now, what term is next? The fourth term, right? If I have the third term right now, what's next? The fourth term. If I have the fourth term now, what's next? Fifth term.
6.
How is 5 related to 4? Well, it's one more than that, right? So we use n minus 1 to represent, that's what's now, so the next one would just be n. Isn't that just one more than this one right here? So in order to know the 7th term, or to get the 7th term, what do you need to know? If I want to go to get to the 7th term, where was I coming from? 6th term, right? Back one. If I want to know the 9th term, what do you have to know? The 8th term. If I want to get to the next term, the 9th one, you have to know the 8th. One less than what you want to go to, right? Make sense? All right. Here we roll. Write in terms of a recursive sequence. This is not too difficult to do. Anytime they ask you to write a sequence here of the first 6 terms, I would say make a table. Make a table. Okay? This is what this says. Write the first 6 terms of the sequence. First of all, which term do they give you? First term. Didn't I say that any recursive rules always got to give you a what? Start. Where are we starting? 3. Okay. So the first term, A1, is 3. It says to write the first one here, guys. So I'm going to go A2, A3, A4, A5, and A6. Bingo!
Bingo.
We play bingo north of Highway 3. Not bingo.
Bingo.
Bingo. North of Highway 3.
I get it.
That's where he lives. Right?
I still want that.
North of Highway 3? It's an inside joke with my family. See, I was the family that I married into.
Oh yeah,
Okay.
you told us this.
Everybody lived south of Highway 3, and they make fun of me for being born north of Highway 3. And I tell them, listen, being born north of Highway 3 meant that you were born in God's country. Okay? I'm just saying. All right? Especially when you pass into Floyd County, Charles City area. Whew, good stuff. All right,
Remember we did that in a big old snowstorm?
Sure.
here we go.
At a volleyball tournament?
That wasn't a big snowstorm.
Listen carefully on this, guys. We start with what value according to this? Start with 3. Now, watch what I do right here. Guys, this A of n right here means the following. What's A of n represent? Which term? My next term. This is basically saying my next term equals, what's A of n minus 1 represent? A of n minus 1 represents your now term. What do you have right now? And to what you have right now, what are you doing?
You're adding
Plus 5. So here's the situation, guys. They said, hey, we're going to start out with that first term being 3. And then this notation is simply saying your next term will equal what you have right now plus how much more? Well, what do you have right now? So that second term right here would be 3 plus what? Which is 8. Now you have 8. So what's the next term? It would be 8 plus 5. So 13. You're just simply adding how much each time? Now you have 13. What's next? 18. Now you have 18. What's next? 23. Okay? Boys, when you get your stuff organized, you can go ahead and head out, okay? Good luck tonight, all right? Good luck. Have fun. Play hard. Have fun, okay?
Punch someone in the face.
No, don't do that.
I was about to do that last time.
Don't you ever do that.
I'm not ever going to do it, but I thought about it.
23. Now I have 23. What's next? What's next?
28.
28. You bet.
That's close too.
You understand this form right here. This A1 means this is how you start. Then this A of n says, okay, your next term is equal to what you have right now plus 5. And you just keep applying the pattern all the way through. Can you handle that? Can you handle that? All right, so the first 6 terms. So here's what I'd like you guys to do. I want you guys to try this one on your own. So right here, I've given you the first term, which is what? 0.5. Half, right? Now, this again is saying right here, A of n in my recursive sequence or in my recursive rule, there's to say in the next term now equals what you have right now, this part, times what? So you're going to take whatever you have now times what? 2. So all you're going to do is fill this out. Your second term, your third term, your fourth term, your fifth term, and your sixth term.
So we just take 0.5 times 2.
So take 0.5 times 2. What do you have right now? You have 0.5. What are you going to do to the now to get to the next? Times it by 2. So what's half times 2, guys? Finish the table quickly.
4, 8, 16. Bam.
Okay. So if I give you a recursive rule with a starting value, can you give me the first 6 terms or so?
Yes.
Okay.
Okay, I already get this now.
That's doable, isn't it?
Yes.
Very doable. All right. Well, the one that I have a concern about then is example 2. And I promise you guys there will be a test question, and it'll probably be the only one about recursive rules on a test, very similar to example 2. All right. Anybody need more time with those first examples up there? Are we good with them? Any questions at all? All right, kiddos. Very good. Let's rock and roll. I'm going to give you some rules about this right here. Guys, example 2 says the following. You have to write a recursive rule for each sequence. Okay, let me give you kind of a cheater's guide to doing this. I think if you can understand that we're talking about a next now type of situation, and if you can follow these rules right here, I promise you you're going to be okay. All right? So here's kind of the rules to this right here. I'm going to put my rules over here. I'm going to call it rules for writing recursive sequences or recursive. Call it recursive formula. How's that sound? Recursive formula. Okay, rules for writing a recursive formula. See ya, Silver.
Yeah.
Good luck.
Thanks.
All right, kiddos, here's the deal. First thing that I'm always going to tell you in a sequence, if you have to write a recursive rule, is to ask yourself, what's your pattern? See if you can't identify a pattern. So in this first one right here, are you okay, Libby? Okay. Do you have a pattern right here? -8 to -1 to 6 to 13 to 20.
Add 7.
What is it again, Tori?
Add 7.
Yep, right here we're constantly adding 7, adding 7, adding 7. So right up here I'm going to write my pattern right down by this. From going from one value to the next. What would be the next value in this sequence?
27.
You took what you had now, 20, and you did what again? Add 7. All right, so the pattern, that part is taken care of. Part 1 on the pattern, that's taken care of. You are going to add 7. All right? Now, part 2 to this. You want to identify a starting value. Okay? Identify a starting value. All right? If I identify a starting value in that sequence right there, what is my starting value? -8. So I have to go ahead and say, okay, to write a recursive rule for this, we have to list the starting value, which is -8. All right, we've listed that as -8. Okay, now this is probably the most important part to writing a recursive rule. Your next value in line is going to equal your now value with your pattern. All right, your next value is going to equal your now value with your pattern. So, look back on the first page of your notes. What notation did I want you to throw in for a next value? A of n. So, okay. So we're going to say the next term, a of n, equals your value, which is right now, which would be, well, not quite. What I'm talking about for terms or notation is this right here. Anytime I use the word next, we replace it with term n. And in the now, we always replace the word now with the term a of n minus 1, or term n minus 1. Okay? So, check this out. Oops. So, this is going to be the next term equals the now term, a of n minus 1. What's the pattern we're going to apply to that now? Plus a 7 right here. Okay? So watch what I do here, kids. Watch what I do here. Isn't this my first term? A of 1. You guys agree with this? This is A2, A3, A4, A5. Okay, so by this rule of recursiveness right here, the next term in line would be the 6th term in that sequence, wouldn't it? That would be like saying, okay, hey, the 6th term, A6, has got to equal, and this is just an example right here. This is the answer I want to the whole problem. But just as an example how this works now, okay, so the 6th term would equal, okay, a of 6 minus 1, which would be what? The 5th term, right? Plus how much more? Well, 7, right? But guys, what was the 5th term? 20. So this would be like 20 plus 7, which you know would have been 27. So do you guys make that relationship between n and n minus 1 saying the next term, or term 6, is dependent upon the term that was before this, the 5th one, or what you have now plus 7 more? That n and n minus 1 stuff makes sense to you now when I start throwing numbers in there? The 6th term is dependent upon the 5th term. All right? Let's try another one. Let's try another one. Guys, take a look at this right here. Using those rules right here, question number 1. What is the answer to that first question to write a recursive statement for this? Divide by 3. So my pattern, I'm going to jot down that my pattern is to divide by 3. Okay. How about your start?
405.
So what are you going to write for your start? So first term equals okay. Now we need to write a recursive statement for this. In other words, we got to say, all right, I've got to write a statement for the next term based on what I have now with the pattern.
So a of n
So a of n
equals a n minus 1. A of n minus divided by 3.
perfect. There it is. There's a recursive rule for it. Okay?
And then do you want us to find a of 6?
Nope.
Okay.
Then if they go in there and say find a of 17, well, there's a problem with recursion. If they say find a of 17, there's a problem with recursion because we don't know what 16 is. Make sense? So, I'm glad you brought that up, Maddie. That's an excellent question because what you just asked really leads into example 3. What if I want to find the 90th term with recursion? You would have to find all 89 before you can find 90.
No, thank you.
No, thank you. I agree. I agree. So, what we're talking about in example 3 is the following. Translating from recursive formulas to what we know as explicit rules. That was either the geometric sequence that we know for the nth term or the arithmetic sequence that you know for the nth term. All right, and here's how this looks. Guys, example 3 really goes back to what you've done in the past. Doesn't part A right here Okay, it's going good. All right. Tori. Okay, I'm good. It's black. It's okay. All right.
Oh my gosh.
Doesn't this look like something that? Doesn't this look like something right here that we wrote right up here for that sequence? So here's the question. We started out by saying, here's a recursive statement. We can generate a table from it. And we've also said we can take that table and we can generate a recursive statement from it. But guys, in the last section, were we able to take a table and use that recursive formula that we had in the last section to write an equation for the nth term? We were, weren't we? So here's what this is asking you guys to do. Guys, they're saying translate from recursive rules, this mess right here, like I have up here in the blue box, and transfer it over into something that's explicit, something that we've done before. This type of a formula or this type of a formula. We just need to determine if something is either geometric or arithmetic. So let me show you how this works. I've got about 2 examples here, and we'll pretty much be done here, okay? So stick with me on this. Whoops, wrong page.
Yeah, I was going to say where.
All right, so here we are, example 3. Here's how this works, guys. I'm going to make kind of a table down here. If they ever give you a recursive formula, the first thing you should probably do is make a table, all right? And I'm going to make a table for about the first 3 terms. So maybe A1, A2, A3. So, okay, guys, in this table right here, what do they tell you term 1 is equal to? 9. All right, now, once I know the term is 9, it says your next term right here is equal to what you have. And I made a typo on this, guys. This should say the following. This should actually say the following. It should say the A of n is equal to the now term, A of n minus 1. Was that a minus 4 in there, kids?
Yeah, negative. Yeah, negative.
Minus 4, like that. So I forgot that minus 1 piece in your notes, so you might want to make sure you get that in there, okay? Okay, so this is really saying, hey, my next term now is equal to what you have right now minus how much?
-4.
Minus 4. Okay, kids, so if I'm at 9 now, where are you at for the second term?
5.
5. And for the third term?
1.
Okay, so I think that's far enough. 9, 5, 1. Identify a pattern at all? Say it one more time, Faye.
It goes down by 4.
Yep, so am I adding, subtracting, multiplying, or dividing?
Subtracting.
So I'm going to say right here to this, following is this. Pattern is subtract 4, right? Now, Maddie, you brought up an excellent point. If I kept going like this, there's really no way of me plugging a number in to figure out what the 100th term would be, right? And boy, it sure would be great if I could come up with a formula to find the 100th term without having to list all of them. You agree with that?
You're going to make me list all of them, aren't you?
Nope, I'm not going to make you list all of them. We're going to cheat this a bit. What we're going to do is this, guys. If the pattern in that table is to subtract 4 and go from value to value to value, does that make this table arithmetic or geometric?
Arithmetic.
This table is arithmetic. All right, so I'm going to split this up. You'll want to write this formula down. I gave you 2 formulas that were explicit rules because, again, we're going from recursive to what? Explicit, stuff that we know. You guys just told me that this is an arithmetic pattern, right? All right, no problem. Here we go. Formula, explicit formula for an arithmetic pattern is as follows. The nth term is equal to the first term, A1, plus a quantity, n minus 1, and I'll squeeze that in there times the letter D. D representing my common difference. How much am I adding or subtracting? Or in other words, what's the pattern value? Well, guys, you said the pattern was subtract 4. So how do you represent subtracting 4 as a pattern value? Subtracting 4 would be what number? Negative 4, right? So what I say here, guys, is this. The common difference in this, for this formula, is negative 4. All right, so just like the geometric stuff you've been working on, your job, plug in your start value, plug in your common difference, and then work your formula to come up with a formula for the nth term in that sequence. So, what's the explicit formula look like here? Here's what it is. This is going to be a of n equals my first term, which is what? 9. That's that a1 right there. A of 1 plus the quantity n minus 1 times your common difference, which we identified in the pattern as what value? Negative 4. Excellent. Squeeze in there, negative 4. So if I want the 100th term now, all I can do is throw 100 in for n, and we'll have it. Now, I'm going to manipulate this a little bit. I'm going to simplify. Do you guys agree I can distribute here and here?
Yeah.
So this becomes the nth term equals 9. All right, what's negative 4 times the n?
Negative 4n.
Minus 4n. What's negative 4 times the negative 1?
4.
All right, how about that positive 9 and positive 4? What's that going to combine to? So my final solution, or my explicit formula, a of n is equal to negative 4n plus how much? So the nth term would be negative 4n plus 13th. So Maddie, if I wanted to answer your question,
Yeah.
well, what about the 100th term here? Take 100 and throw it in here, times it by negative 4, and then add 13. Check it out. What was the second term in this, guys? 5. Throw 2 in here. What's 4? I'm sorry, negative 4 times 2. What's negative 4 times 2?
Negative 8.
Negative 8 plus 13 more puts you where? 5. See how that works? So we took something that was written with a start. They identified a pattern. We went ahead. We kind of set a table up. We said, all right, once I've got this table up, the pattern is to subtract 4. Since subtracting 4 is an arithmetic sequence, we apply this explicit formula. We plugged in your first term, you plugged in your common difference, and you were on your way. All right?
That seems easy.
Are we just going to go to example 4?
We're going to get there. I'm not going to worry about that one too much today. I've got one more I want to do with you guys. Make sure we're okay with this. By the way, everybody have that down? Anybody need more time with that page? Got what you need? What's that? Sure.
No.
Yeah. All right. Let's do another one here quickly. Okay, so I have a recursive formula up here. I have a recursive formula. They give us a starting value of how much, guys? Whoa, I don't want that.
That's a cool color there, P.
P. Diddy. What did P. Diddy?
What?
Huh? I don't know what I
I
said.
am already confused.
I'm confused too. What's my starting value for this?
4.5.
4.5. Okay. Again, what type of formula is given here, guys? Recursive or explicit?
Stop it.
What kind of formula is this up here?
Wait, what?
Is this recursive or is this explicit? This is recursive. They give you a start and then a pattern. We want to take this recursive formula and write it as an, what we call explicit formula. All right? Make sense there? All right, here we go. So let's fill in some values. So they tell you that term 1 is 4.5. All right? Now, according to the recursion right here, it says your next term is equal to your now term times what value? Your next term equals your now term times what? 3, right? Times 3, right?
Yeah.
Sweet. Listen to what I said. Times 3. We're going to times by 3, times by 3, times by 3. Let me ask a question. In that recursion, when I say let's times stuff by 3, do you think that makes your sequence geometric or arithmetic? Geometric, right?
Yeah.
Geometric, because you are multiplying by what?
3.
Here's a better question. What do you think the common ratio might be? 3. Let's just see if it's true. Somebody take 4.5 times 3 for me. 13.5 times 3. Okay, do this for me. Let's just make sure my pattern's working out. What's 13.5 divided by 4.5?
3.
3. What's 40.5 divided by 13.5? Yeah. This is definitely what type of sequence? A what metric?
Oh, yes, it is.
Geometric. Been a long week, hasn't it, Kylie?
Yeah, it has. Her knowledge is running short.
They cut off too much hair, didn't they?
No, did you just hear what I said?
No.
I said her knowledge is running short like her hair.
Ah, that's pretty good. You've got to give her that, Kylie. That was pretty good. Okay, even though it was mean,
Even
it was
though
good.
I like it better when it's short.
I do too. I think it looks good. I think it looks nice.
It looks healthier.
I think it looks nice, Kylie. Seriously. Okay. Faithers. Yes. All right, let's finish this up. Huh?
5 minutes. Yeah, I figured that out. It's always waiting.
Faithers.
It's just natural right now.
Go.
Wait, what?
Levi. Hustle.
No. I'm sorry. You can't.
Geometric sequence. You guys should have this formula memorized for the last section. What's that geometric formula, guys, for the nth term?
Equals A1 minus 1. A1
Dude,
and
good
then
God.
R and minus 1.
Okay, so we're going from recursive right here, which is this next now stuff, into one formula for any term. So, here we go. What is term 1? What is term 1?
4.5.
What's your common ratio?
3.
Stay with me.
What is that though? Is that?
There it is. Here's your formula. There's your formula right there. So, guys, if I wanted to know the 28th term right here, I could go into this recursive formula and keep listing everything out until I got to 28. Or I could take recursive formulas, rewrite them as an explicit since we know it's geometric, throw 28 in for n and solve that way. Would you rather do that recursively or geometrically? I should say, would you rather do that recursively or explicitly then? Explicitly. Okay? All right, so that in a nutshell is really what's going on today. I'm going to take time a little bit on Monday just to talk about this. We're not going to get into this too much. Everything that you need to know for your 5 problem assignment on 6.6 is in the notes. Okay? So I'll go ahead and stop this here.